Hi, my name is Paul. I'm presenting a paper on machine learning model, resource monitoring for virtual machines in cloud computing. Some of the keywords for this project is we have cloud computing, source monitoring, virtual machines, ARIMA, LSTM, Facebook Profit, CPU, time series, and forecasting and sharp, then explainable AI. Yes, in introduction, this paper presents presents machine learning model for resource monitoring for virtual machines in cloud computing using supervised learning techniques. The model focuses on CPU utilization of virtual machines on VMware, and it is trained using a dataset of over 20 virtual machines that have been running for a period of 365 days. The goal is to reduce the unplanned downtime for services running on these VMs, leading to a series of catastrophic failures. The proposed solution is to use time series forecasting methods ARIMA and LSTM to come up with the best performing model using this large and diverse dataset. Explainable AI techniques such as sharp. Sharp values is applied to make the results of the model more transparent and interpretable, allowing better understanding of the model, decision-making process, and ensuring ethical and societal alignment. The contribution, is a diverse dataset of over 500 data machines running a period of 365 days on VMware and will be used for this model. Our model applies two times series forecasting method, that is ARIMA and LSTM, and uses the explainable AI technique of sharp values to make the results transparent and interpretable. Real-time monitoring of virtual machine resources utilization is also implemented. The performance of the model is evaluated through cross-validation and grid search. Our contribution aims to improve efficiency and reliable cloud computing systems. The methodology. A time series refers to a sequence of observations that make a record for a particular activity over a period of time. Forecasting is an activity or an observation usually involves collating its historical time series and finding patterns in them. Transforming a time series into a smoothened out version, then plotting it can reveal patterns that were previously unknown. One such commonly used smoothing technique is the moving average. Moving average method is used for measuring seasonal variations in the time series for computing the arithmetic mean values for time interval throughout the time series and reducing any volatility in the data. Autocorrelation function, that is SCF over time series, is the amount of the correlation that current values have with the past values. And the SCF and the partial SCF plot help identify any seasonal patterns in the data. ARIMA models. So white noise is a time series where each observation randomly draws from population with a variance and a mean equal to 0. Time series are required to follow such patterns for better forecasting and any observation from this amount violation. Then we have autoaggressives and moving averages are two models that help rectify these violations if identified. A stationary series is said to have no trend with constant variation in mean fluctuations with constant patterns. This means that the auto-variations would remain constant and form a consolidation of the signal and noise. ARIMA models can be used to act as a filter that separates the signals and the noise after the signal is used to forecast values in the future. ARIMA models is noted by the ARIMA with the variables P, D, and Q, where P is a total autoregressive terms, i.e. the ARR terms. D is a total differences needed for stationarity, and Q is a total lagged forecast equal errors while forecasting the MA terms. Identifying the relevant ARIMA model a given time series involves determining the values of P, D, and Q. Determine if AR and MA terms are necessary, SEF and PSCF loads are used in this particular activity. Then the LSTM networks, we have artificial neural networks are a computational paradigm that mimics the biblical neural networks through a network of connected computational units called neurons that are organized as layers. LSTM networks are a class of RNNs that are used to interpret and learn even long-term dependencies. The major features associated with the LSTM networks are the ability to retain and persist information for a longer series of time. Of course, this is different from ARIMA, which retains for a shorter period. So the LSTM networks have 4 processing units within a single repeating unit, as shown in the figure below. The line that runs through the repeating mode is the diagram. In the diagram is the cell set that runs through the entire LSTM network, modifying information as it traverses. The pink blocks, as you can see in the figure, represent a module called the gates that modify the cell state optionally. ARIMA modeling. In order to assess stability in the data, moving averages summary, moving MAs, that is the moving average summary points, where computed for multiple values from the time series, which potentially smoothen out the raw data. ARIMA models are good for forecasting model for near prediction, but fails to predict a much longer term CPU usage. The results of the ARIMA model for other machines are also similar, where the forecast follows the same pattern as the actual data for the near time prediction, but the model loses credibility in making long-term predictions. Okay. LSTM network modeling. The activation function of the LSTM is a turn function, which can output a value between -1 and 1. Hence, the time series is transformed by normalizing it within the range before splitting it into training and testing data. The parameters were tuned, and after training multiple LSTM networks with different combinations of training epoch on the number of neural networks in the hidden layers. The LSTM models were fit, and the varying number of neurons and their RMSE and MAPE values were calculated. After tuning the LSTM hyperparameters, a final LSTM model configuration that yielded the best results were configured to one hidden layer, 5 neurons, and then training epoch of such to 3000. For machines whose CPU usage time series was significantly different, were modeled according, but exhibited just a slight fluctuation in the results. CPU usage for machines in the data center always has a dependency between the previous and the current values. This phenomenon makes the CPU usage time series and AR process. LSTM neural networks, especially being an nonlinear time series model, performed better than ARIMA model. Almost all combinations of hyperparameters. ARIMA models were observed to be prone to overfitting for models, CPU time series for machines. They performed well in terms of training the root-mean squares values, but poorly in the test data. On the other hand, LSTM models for all the machines were consistently performing better without any significant fluctuation in model performance. In conclusion, forecasting of CPU workloads of machines in the data center using LSTM networks has shown significant improvement over the ARIMA model. Thank you very much.